All right, so transformations. So this will be our last video for section one. Oh, I messed up. It's okay. I'm going to do reasoning and transformations together. So we'll just have a couple extra videos. So transformations, the role intuition plays in formatting mathematical thoughts is truly significant. But to have an idea is not enough. Testing a theory may lead to a revision of the theory or even to its total rejection. If a theory stands up to a testing, it moves one step closer to becoming a law. So this is where that induction and deduction and so forth come into play. So we're working our way through. So let's repeat that one more time. If a theory stands up to testing, it moves one step closer to mathematical law. So induction. We often use specific observations and experiments to draw a general conclusion. This is the reasoning that is called induction. So you're doing something, you have an observation, you're whatever it is, whether it be at work, whether it be in life, whether it be about anything, you see something happening, you make observations, or could be you perform some experiments to kind of like you're like, oh, this seems to be working. Maybe it's in the kitchen. You're like, oh, if I use this ingredient, it does this, and so it's like that's kind of like the idea of induction. As you would expect, the observation and experimentation process is common in laboratory and clinical settings. Chemists, physicists, doctors, psychologists, weather forecasters, and many others use collected data as a basis for drawing conclusions. All right, in geometry class, you have been asked to measure the three interior angles of each triangle. In figure 1.4, you discover that triangles 1, 2, and 4 have two angles as marked that have equal measures. What may you conclude? And so we can kind of go through, let's see what's on the next slide. All right, so if you want to hit pause for a second, kind of think about what you conclude. So if we know that in this triangle right here, those angles are the same. This triangle right here, these angles are the same. And this triangle right here, those angles are the same. Right? It's not that we're saying what can we conclude about all three of them together, but independently, what can we conclude? All right, so here we go. The conclusion is that the triangles have two sides of equal length, also have two angles of equal length. And so we can say that because we can see that 4 and 4, oh, that angle is congruent, that angle is congruent, the sides are congruent. 5 and 5, angles are also congruent. 3 and 3. So we made some observations, we used induction to be able to conclude that those angles would be congruent. All right, or if you have that scenario, then you have these congruences. All right, so whereas in deduction, it's a type of reasoning in which the knowledge and acceptance of selected assumptions guarantee the truth of a particular conclusion. So in example 8, we will illustrate a valid argument, a form of deductive reasoning used frequently, in the development of geometry. In this form, at least two statements are treated as facts. These assumptions are called the premises. So it's kind of like what we're building up to. And so the premises are kind of what we have kind of like lingering there in the beginning of the problem. We've kind of maybe been introduced to it. They've maybe said, hey, if you have these things happening, what could you conclude? On the basis of the premises, a particular conclusion must follow. This form of deduction is called the law of detachment. All right, so if in a statement, if P then Q, it often implies that P implies Q. It's often read as P implies Q. Then if P is known to be true, then Q must follow. So if P is true, then Q would be next. If you accept the following statements, 1 and 2 as true, what must you conclude? So question 1. If a player plays on the Rockville High School boys varsity basketball team, then he is a talented athlete. Todd plays on the Rockville High School basketball varsity team. So can we conclude? Well, if a player plays and Todd's a player, then he must be a talented athlete. So we can make that conclusion through deduction, or the law of detachment, I guess I should say, right? So that it's this idea that if we have one, then that leads to the other. All right. So to more easily recognize the pattern for deductive reasoning, we use letters to represent the statement, the following generalization. So this is an important thing to write down here, this law of detachment. And as we read this, what it's essentially saying is that saying that, like, if we're giving this first thing to start off with, which you can kind of think as your premise if you want. So like if we start off and say if P then Q, that's our premises, right? Those two statements. And then we say, okay, well, P is happening. So we have a student or we have someone that meets P, then that implies Q. So these little, the 3 dot symbol means therefore, or so therefore Q. So this is definitely something to write down in your notes, law of detachment. All right, so we will use deductive reason throughout our work in geometry. For example, suppose that you know these 2 facts. If an angle is a right angle, then it measures 90 degrees. Angle A is a right angle, then therefore we can say that angle A is 90 degrees. So that's the law of detachment. All right, we'll stop the video right there and come back with Venn diagrams.